Okay, good morning everyone. So today's topic, calendar. I am Swamyajulu from Srivasam Engineering College, Aptitude trainer. So today we are discussing related topics about aptitude and reasoning. In that I am choosing one of the topic, the best and easiest way to solve the questions for all the competitive examinations, including placement drives. So one of the easiest topic, that is calendar. So mainly the basis of questions related to calendar, how they are asking. So particularly they are given one particular date, for example 15th August 1947. Find the day on 15th August 1947. So we are identified the day on that day, 15th August 1947. So related to the dates are changed or years are changed, but the questions are pattern of the same procedure. So to identify the day, first of all we need two points in this. The one point is identification of leap year. So leap year identification everyone knows. The definition of the leap year, generally we are taking when it is divisible by 4, it is called a leap year. So example of identification, for example 1964, identify whether it is leap year or not. So leap year definition related to that, it is divisible by 4, but we need not to divide entire number. Divisibility rule of 4 is the last two digits are divisible by 4, then the number is divisible by 4. So here the last two digits are 64. Last two digits are 64. So consider that 64, it is divisible by 4, therefore leap year 1964. Similarly, one more number, for example 1980. 80 is divisible by 4, therefore 1980 is also leap year. If you consider 1982, the last two digits are not divisible by 4, therefore this is not the leap year. So this is identification of leap year in a general year. But there is a condition for identification of centuries in the leap year. Even though we consider all these numbers, some centuries ending with two zeros, 100, 200, 300, all these numbers. So even these numbers also divisible by 4. It is exactly divisible by 4, but 100 is not the leap year. Similarly, 200 is divisible by 4, but it is not the leap year. So consideration of centuries, when a century is divided by 400, then it is called leap year. Century, when it is divided by 400, then it is called leap year. So this is the identification of leap years. So what is the first century leap year? The first century leap year is 400, and the next century leap year is 800, and the next 1200, 1600, and so on. These are called leap years. So this is a particular identification of leap year. So that is the first fundamental required in calendar. So if you identified leap year, then the problem solved. It's very easy. And one more, next. Second point is finding odd days. Odd days in calendar. What is meant by odd day? Generally, even days and odd days. So in mathematics, even and odd are relatively different. So even means we consider that 2, 4, 6 and so on. These are called even numbers. Similarly, 1, 3, 5 and so on, they are called odd numbers. This is related to mathematical symbolism. But in calendar, the odd days are different definition. So what is meant by odd day? If you know that odd day, 90% of the calendar is solved, simple calculation, and we are using the same method for odd days finding, identification of the day. So what is meant by odd day? Odd day means a particular number of days. A particular number of days when divided by 7, the remainder is called odd day. So this is the definition of odd day. a particular number of days when divided by 7, the remainder is called odd day. So I'm considering a simple example for that. For example, there are 10 days. 10 days when divided by 7, what is the remainder? The 3 is called remainder. So for 10 days, the number of odd days are 3. Similarly, if it is 20 days by 3, the odd days are 6. So similarly, some more odd days we calculated. 15 days. 15 days odd days when divided by 7. The concept for odd days is when divided by 7. 15 days, the number of odd days are 1. Similarly, 30 days. 30 days means 30 when divided by 7. The remainder is called 2 days. So this is identification of the odd day. So here we consider one more point. So for particular number of days, for example 63 days are there. 63 days means 63 when divided by 7, the remainder is called 0. So 0 odd days for 63 days. The more number of days when divided by 7, we are identified that simple odd days definition. But we are having in a calendar related to there are 12 months. So related to how many odd days for the month of January, they are asking. So month of January, how many days? January is having 31 days. When 31 is divided by 7, the remainder is called 3. So January month, 3 odd days are there. Similarly, you consider any other month. The month of April. April is having 30 days. When divided by 7, the remainder is called 2 days. So for every month we calculate odd days similar manner. Similarly, in a year, if you consider that 1 year is equals to how many days? 365. When divided by 7, the remainder is called 1 day. 1 year, the number of odd days are 1 day. If it is a leap year, then leap year means generally how many odd days? 1 more day. That means 366 days when divided by 7. Normal year 1 odd day. Therefore leap year having 2 odd days. So this is identification of a calendar, particular 1 year or leap year, the number of odd days. But still we need to remember one more point. For 1 year calculation, for leap year calculation, it is easy. Even for 2 years also we defined it's very easy. But in the calendar required 100 years. Odd days for 100 years. So simply you remember here, I will explain when the sum occurred, how to find that 100 years odd days. But remember here, I am given a logic for that 100 years, the number of odd days are 5. Please identify. So this is very important. For 100 years, how many odd days? 5 odd days. If 100 years, 5 odd days, then 200 years. The number of odd days. For 100 years, if it is 5, 200 years, 2 5s are 10. 10 days odd days. 10 means again we know that when it is divided by 7, the remainder is called 3. So 200 years, 3. 300 years, 3 5s are 15. 15 when divided by 7, the remainder is called 1. When 400 years, 4 5s are 20, but every 400, already we discussed about that leap year definition. For every centuries point of view, every 400 years there is a leap year. Therefore 20 plus 1, here we will get 21 days. 21 days means number of odd days are 0. So it is a very easy identification. The descending order of the numbers: 100 years 5, 200 years 3, 300 years 1, 400 years 0. So simple identification: 5, 3, 1, 0. So descending order, these are the number of odd days calculation. So this data is enough to solve various examples in calendar. Now we will apply these logics in the question itself. Please consider all these points. Finding odd day is 90% of the accuracy gives in calendar, and leap year identification 10%. Totally 100% we resolve that question. Now we are taking that example, 15th August 1947. 15th August 1947. What was the day? Find the day on 15th August 1947. So first there are two steps to identify this question within a minute. The first step itself is its expansion. Expansion of the year. The year is 1947. So the first step we are taken here, it is, we discussed in the last point, for every 400 years there is a 0 odd days. Every 400 years 0 odd days. So the same base we applied here. So here how many 400s are there? 1947 means there are 4 400s are there. So 4 400s are 1600. So first step, always you consider that out of 1900, 1600, because it is 4 400s. And remaining how many centuries are here? The number of centuries after 1600, 3 centuries are there. So we consider that is 300. Remaining years, centuries after, it is 47 years. But 47th year is running. So 47th year is running, therefore we consider up to completed years 46, and this is called remaining days. This is the first step for expansion. It takes maximum of 10 seconds of time. So first step is multiple of 400, remaining centuries, remaining years, and the remaining days. So this is the calculation. And the next step, this is identification of leap year or whatever it may be, 10% here and the remaining 90%. Now we conclude resulting answer. So for 1600 years, the number of odd days. Just now we discussed about that. For every 400 years, the number of odd days are 0. For every 400 years, the number of odd days 0 means 1600 years, the number of odd days is 0. 400, 800, 1200, 1600. The multiple of all 400s gives the number of odd days are 0. Similarly, 300 years, finding odd days. 300 years means, first of all, the number of odd days per 100 years. I am given the basic concept 5. For 100 years, if it is 5, 200 years 3, 300 years 1, 400 years 0. Therefore here 300 years, the number of odd days are 1. Next, the main crucial and where we did a mistake, that is here only. So please concentrate here. The number of years, here how many years are there? 46 years are there. Identification of odd days for this 46 years. So this is the main base. So generally the students are making a mistake in this step itself, otherwise they are accurate. So similarly, see here, for 1 year we discussed that 1 odd day. 1 year, 1 odd day. 2 years means 2 odd days. If it is 3 years, 3 odd days. If it is 4 year, we know that every 4th year is a leap year. So for leap year means there are 2 or more odd days. Therefore 4 years means the number of odd days are 5. So instead of that division, identification of odd days of leap years and normal years, first generally you consider all the 46 years. All the 46 years is normal years. So 1 normal year, 1 odd day. Similarly, 46 years, 46 odd days. So 46 odd days means, according to the definition of odd day, when you divide it by 7, the remainder is called odd day. 46 when divided by 7, the remainder is 4. Similarly, identification of leap years. So we know that every 4 years once there is a leap year. Therefore 4 years once means how many leap years are there? When divided by 4, we got it, there are 11 leap years in this. 11 leap years, 11 days extra. 11 days extra means 11 days odd days is considered as 4. 11 days when divided by 7, that is considered as 4. And the remaining last step, days. In this, the number of days, how many days are there here? 15 days. 15 days odd days. Again when divided by 7, the remainder is called 1. And remaining months, So this month's calculation purpose, January, February, March and so on. There are 12 months are there. For easy identification purpose, I defined a number 3032323, 32323. So this is easy identification. So this is the code language for all the 12 months. 3032323, 32323. So every month the number of odd days here I defined. So similarly here 8 months are there. Therefore 7 months completed. 8th month is running. 7 months completed. You consider the first 7 numbers. So add this total 7 numbers. 3232, 10. 10 plus 6, 16. 16 means the number of odd days are 16 days odd days is 2. 16 days odd days is equals to 2. Now you consider that 4 plus 1 plus 2, 7 days means 0. 4 plus 1, that is remainder 5. 5 is indicated as Friday. So the first Independence Day, 1947, 15th August, is well known about that Friday. So this is the clear example. We will solve 2 more examples related to this. Later on we go for practice exercise. Just go back one more date I am given here. See that 26th January 1950. 26th January 1950. So as we discussed earlier, the first step itself is distribution or division of the year. So 1950, first step, multiple of 400s. So how many 400s are here? There are 1600, 4 400s, 1600. And remaining centuries are 300. Remaining years 49 and remaining days. So this is very simple. First step, concentration only on year, dividing the number of 400s, remaining centuries, remaining years, remaining days. Now identification of odd day is the next step. Identification of odd day means for every 400 we discussed that odd days are 0. Therefore 1600 years the number of odd days 0. For 300 years, for 100 years we defined that is 5. 300 years it is 1. Now here the step considered, we first divide with the 7. 49 when divided by 7, the remainder is called 0. 49 when divided by 7, remainder is called 0. So identification of leap years. So for every 4 years once leap year, therefore there are 12 leap years here. 49 when divided by 4, 12 times 4 table divisible. Therefore 12 leap years are there. So each leap year 1 day extra. Therefore there are 12 days. 12 days odd days again. 12 days means the number when divided by 7. The remainder is called odd day. So that is equals to 5. And that last step, here we consider that days. 26 days odd days. Again odd day definition. A number when divided by 7, 26 when divided by 7, the remainder is 5 here. And January month not at all completed, therefore need not to consider the remaining months. So this is final. 5 plus 5 plus 1, 11. 11 means when divided by 7, 4. So this indicates that Thursday. This is one more example, identification. So previous thousands of years or after thousands of years, it takes just 1 minute of time for identification a particular day in the calendar. And last example for your practice, so I will consider today's date. So today's date is 21st October 2024. So what was the day? Today's day. So we know that today is a Monday, but we will just check it whether it is Monday or not. So based on our practice, the first step is separation or filtration. 2024, expansion of 2024, multiple of 400 means 2000. there are no other centuries, 0 centuries are here. So need not to consider that centuries. Remaining years, 23 years and remaining days. So this is the first step. Actually previous two examples, here centuries also there, 100 or 200 or 300 that we mentioned, but here centuries are 0, so need not to be mentioned. If you want, mention 0. Now for every 400 years the number of odd days are 0 we consider, and here first we multiply by 7, the remainder is called 2. Number of leap years, for every 4 years once a leap year, therefore there are 5 leap years. 5 when divided by 7, the remainder is called 5 only. And that last step, days, 21 days. Identification of 21 days, odd days are 0. And months, the number of odd days per months. So it is October. So generally I am given that number 32323, 32323. So this is the 12 months odd days number. So how many months completed here? There are 9 months completed, not 10. 9 months. So count that 9 months, sum of the numbers, 10, 13, 16, 18 plus 4, 22. So 22 days. 22 days finally the odd days are 1. 2 plus 5, 7 days means odd days is equals to 0. Finally I got 1. 1 is indicated as Monday, 0 indicated as Sunday, 6 indicated as Saturday. So 1 is Monday. So we are clear. Today is Monday, that is 21st October 2024. So similarly in a calendar, any particular date using that 2 steps within a minute. Here the concept is identification of leap year 1 and the second one is finding odd days. There is no other required, not required to remind or memorable any thoughts, any formulas related to this calendar. So simply we know about the date. And some questions related to calendar in the placements or competitive examinations, how they are asking. Just 2 or 3 examples, then we conclude this. For example, 21st October 2024 is Monday. This we know that. So he is asking that what was the day 21st October 2025. Find the day on 2025 October 21st. So 1 year after, next year the same date, what was the day? So we know that 1 year, 1 odd day. 1 year, 1 odd day, therefore 1 day extra, therefore Monday plus 1, next year it comes, that is equals to Tuesday. So in the question simply if they mentioned finding the odd days. Otherwise the same question, today is Monday, if he is asking 21st October 2020 or 22, what was the day? 2 years ago he was asking. So if it is forward, then we are adding plus 1. If it is backward, then we are taken, that is minus 1. So 2024 is Monday. If 24 is Monday, then what is 23? If it is minus 1, we got it, that is Sunday. But here leap year is adding. Leap year means 2 odd days. Therefore 23 minus 2 we will get, that is on Saturday. In 22 minus 1 again, so we will get Friday. So 2 years ago or 2 years after. For example 24 we know that here. What was 2030 he is asking in the same question. So more number of examples based on single question here I am explaining. So 2030 means a lot of difference from here to here. But how to calculate? If it is 2024 is Monday, then simply you note down 25 is Tuesday, then 26 is plus 1 again Wednesday, 27 plus 1 again, that is equals to Thursday, 28 again plus 1 Friday. See here, 28 is a leap year. Leap year means 2 odd days we are getting. Generally we consider +1 only, but whenever if it is a leap year, +2 will be considered. So instead of Friday, here we are taken that is equals to Saturday. 28th is Saturday, 29th is again +1 Sunday, again 30, 2030 again Monday we will get. So this is identification after 10 years or before 10 years. Simply we consider based on odd days identification plus or minus. So this is one more model related to that they are asking, and last model in a calendar. So the last model, for example 2005. The calendar 2005 is same as dash. The calendar 2005 is same as dash. When the same calendar it will be appeared, that means if January 1st 2005 is a Sunday, then the other calendar also January 1st is Sunday. If December 31st is Monday, in this calendar the December 31st also Monday. So all the dates are coincide related to calendar 2005 and related to that other calendar. So this is the identification. This is another model. So we will conclude with this example. See this 2005, you consider the first day of January is, for example, this is you consider any day that is equals to Friday. 2005 is a Friday. So which calendar is appeared again the first day of January is Friday. That is required for us. So same as previous example, we know that 1 year is equals to 1 odd day. So 1 year is equals to 1 odd day means if 2005 is Friday, simply note down 2006 what was the day. So this is equals to Saturday. 2007 is equals to Sunday. 2008 is equals to Monday. +1 every year 1 odd day, therefore always we consider that is equals to +1. But when 2009 it comes, 2009 comes, what happened in this 8 leap year? Leap year means in this calendar February 1 more day is added. So that way +2 will come here. 2008 to 2009, here the number of odd days leap year is included, therefore +2 will come. Therefore instead of Monday after Tuesday will not come, it is equals to Wednesday. Then 2010 is Thursday. 2011 is Friday. So already 2005 is given Friday, therefore 2011 January 1st is also Friday, and these two are the same years, they are not leap years. So January to December all the dates are coincide, therefore we defined according to this data the calendar 2005 is same as the 2011. So basically this information is enough for the competitive point of view. Or more examples and more practice we will discuss about in the practice section. I will display some questionnaires, and based on that questionnaire you solve all the questions, and how to solve that questions based on that examples and objects which is given options, how to choose within a minute we will discuss in the next section. Thank you everyone.